a lot of people feel similarly that, well, AI is just another kind of complexity, and we still have the same problem with complex systems, and so we should take it in its context as being just another source of complexity and a yet more complex system. And on the other hand, when you actually look at how complex systems are evaluated, they fall into certain kind of traditions and categories, right? There's certain kind of cultural features that you can see inside of a system, and you want to exploit that as part of your evaluation. So I think, would you consider maybe a hybrid model where we say, yeah, the AI capability is embedded in a larger system, so we have to adapt how we evaluate the system, but also we want to exploit what we know about how the AI is done and the data and everything else. So and then how can we actually accomplish that exploitation? What are the tricks that we can apply based on what we know about the AI algorithms and how they're constructed? Does that make sense?
Yes, it does. In fact, there is something special about AI, and I think Richard and Andrew pointed at it, that even distinguishes it from complex software.
Yeah.
And one of the things, to me, the main thing that distinguishes it from other complicated software is that it's that if it's a learning system, then there's no way to pretest the software before you field it.
Yeah.
And that's a qualitative difference. There are probably others. How you deal with that, I'm not sure, but I do think that, again, maybe the main point of my talk was that we can both try to instill safety into the component parts of large systems. That's a useful enterprise. But at the same time, we could think about having a safety agent hovering over the whole system so that we get to attack the problem from both ends.
One of the issues with the hovering safety agent is plenty of large deployed systems these days are doing massive surveillance, almost like epidemiology, to check. Maybe my system is behaving strangely in China at the moment among users who are traveling on rainy roads or something. It's constantly asking these questions. And of course, you ask 1 million of those questions, thousands of them come back as very significant at the 0.1% level. And I think we have to, it's not enough. It's easy to draw a diagram showing something and an example where some value goes out of spec, and we say, well, the system's now going to hand over to a computer. But really, I actually have not seen practical implementations of that without having a bunch of human experts there really able to do some of the deep diagnosis of the system.
Yeah.
So I don't buy watching for anomalies by itself as a very practical solution.
Humans
Can I
are
ask?
outside of
Can I
space.
ask? Can I ask Andrew a question? I think I'll say, assuming that you agree with me that sensors and the diversity of available sensors is going to grow dramatically over the next decade, making it possible to have really redundant sets of sensors available. Do you think that will ameliorate the problem you're talking about?
I think you're absolutely right to say that you want multiple sources of independent information will really help.
I'd like to expand that. It's not just information that's that you can do inference on, just actual data gathering, but there's many different types of safety that we've all talked about today that should all come together. I mean, you can't just have one of these techniques and then inject it and say, okay, now the system is safe. It needs to come from multiple different angles.
I think it really comes from Andrew and Richard's presentations. And so, going back to the question of the deer, let's say there's a particular culture which holds the deer as a sacred animal and says that one deer is worth 1 million human lives, and they put it that way. So I don't know if there's an answer to the question, but what is your viewpoint on what would be the final arbiter who decides the value to be the it a cultural issue or a social or a policy issue or a scientific issue? And how do you square that with the fact that a lot of cutting edge AI development is in North America and the UK, when they have any attendant kind of corporate biases?
Do you want to take that, Paul?
Sure. So, yeah, when it comes to things like self-driving cars, I think it probably does make sense to have a few different levels of preferences. Probably some preferences like it's okay to go slightly above the speed limit if you're doing that to keep pace with the other cars on the road. It's something that, although technically not legal, possibly in some places, is something that is quite acceptable. So we give a lot of leeway and penalize that very little bit for in the general scheme. As where something like driving on the sidewalk might be highly irregular, and we'd like the owners of the car to not have too much leeway in actually choosing to let the car do that. So I think it probably needs to be a layering where it's a combination of civil society and regulators and manufacturers and potentially human rights organizations or animal rights organizations, as well as the actual owners and operators of AI, kind of all coming together and sort of layering on their preferences. And to do that, I think that there needs to be some amount of preference factoring, where we could actually start talking about preferences using common terminology and common understandings.
I mean,
I really like the concept of these AI safety agents, but I think there's a huge range from the very simple ones like the lane drift detector or the imminent collision detector that is coupled with an immediate reaction, slow down or get back on your lane, to the opposite end of the extreme end is keep the power grid going or prevent a nuclear meltdown. I think that the latter category has these one-off events that are really not predictable. We cannot get our machine learning machinery to work well for a lack of historical data. But I think there's a lot in between those two. So, for example, we're working with a company, never mind the name of the company, I don't want to advertise. But it has to do with workplace safety, where there are many incidents and behavioral patterns. And to the degree that you can advise how to change these, you reduce the number of workplace accidents. That's a different kind of safety agent that changes behavior, human behavior, rather than changing a setting on the machine. And there are all kinds of other things intermediate to the one-off disaster versus the how the heck many times have cars started to drift away from a particular lane. One car would have drifted maybe hundreds of times, in which you have millions of data points. And so I think the sweet spot is starting from the simple ones that replicate many times going forward, but not necessarily, shooting for the moon is okay, but shooting for Pluto might be hard.
Yeah, and as you say, bringing people in you don't have to maintain total autonomy all the way down that spectrum. Bringing people in, and once you do, it raises issues like being able to communicate to that person what the system has actually perceived and what its modeling suggests might be the diagnosis and the therapy.
Some of the things that you're talking about, the management of world models and information functions, which we're talking about. When we're talking about intelligence, generally, the way that I think about it is that you're really talking about systems that are now able to engage and then go autonomous, and engage and go autonomous. And when we deal with mature work, it's actually systems that can do are very adept at being able to engage and go and then working through themselves. So for me, when we talk about safety and control, it's what is the benefit of having systems that we are not necessarily restricted to just doing these complex multimodal fusion problems with, but systems that can say that, I've achieved this level of synthesis, I've achieved, some level of origination in just this capability that I have built up. How would we reorganize in a value system that makes the system more safe? So that's the way I think about it more, is that what we're looking for with artificial intelligence is not to be prescriptive about things, as saying, and we're hovering around this, and we will only allow certain types of work. Is that the more prescriptive we are, is that the less mature the work involved.
So I think you're hitting on something which always bugs me. It's and by the way, I very much support your comments. When integer programming came in, a fantastic optimization technique, somehow those guys and the women involved as well, when they brought it in, they just got all the credit for making systems more efficient. We actually had much better logistic systems. We're able to keep the world fed because we're distributing stuff properly through integer programming. And there, it was, I think one of the things that helped us there, it was pretty clear for most of those systems, we had very clear cost functions. Like we want to reduce the amount of wastage, we want to reduce the number of people unemployed waiting for their jobs so we can schedule their shifts properly using IP. Now, we've got to the level where we're really having to ask harder questions of what do you want? And I do actually believe that Microsoft Cortana will, within 5 years at the end of every day, be asking me the question, are you happy with how the day went, Andrew? Was it kind of what you expected? Are you happy with the last year? And the biggest questions are going to be, what do we really want? And how do we deal with the fact that in a very a society which is very open and full of many different ideals, to get the full benefits of these really vast adaptive optimization systems, we still have to tell them what we want. And so it's going to get harder and harder for us.
And
Right now, because what they're doing is a lot of people say do the evaluations after the class, but more and more people are saying present the evaluations before the class and after the program for the work that people are doing.
Hi, this question related to the driving car issue. So the concern that many non-technical people have, even things like pop culture, is of the idea of AI like rising up and harming humans. I agree that it's a very nuanced decision to quantify that hash defined. But let's say once we start having that conversation and attaching numbers to it, how do we reassure like these non-technical people that there won't be a scenario where it's in the interest of an AI system to actually harm a person? Because now it's a number, it's not a case that I will never consider. It's still some number, maybe for self-preservation. In some case, the policy incentivizes actively harming or even killing a person. So how do we reconcile these two aspects once we start having that conversation?
Yes, so I think there's two separate, really big dangers. Danger one is that someone foolishly or naively puts what they think is a really wonderful AI system in place, maybe to protect schools or something like that, and it's got something disastrously wrong with it, and so its objective function, it misapplies it, and maybe people die as a result. That is an awful tragedy, and I think there is a danger of it happening. And we, as an academic discipline, will be rightly pilloried if and when that happens. That's one class of problems, and it's closer to the known dangers types of things. And we were going to use engineering disciplines and statistical disciplines to deal with that. I believe, and you guys can disagree if you like, that is conflated at the moment in the public's mind with this other danger that there's going to arise some sort of superintelligence which is a very different kind of unintended consequence of making us all irrelevant and actively plotting against us, or those kinds of things. For the general public who are worried, I don't think they can really see the difference between those two dangers.
We're going to take two more questions. In the back.
From a policy perspective, the normal fallback position for safety is that if you introduce a new product, that it shouldn't increase the safety, the danger for the general public more than what we already have. So if that's the case, and you can show that your system doesn't kill deer more frequently than it did before, than we see right now, does it really matter when you prefer to hit deer versus humans?
So it is going to be a nightmare for us when a car decides to seriously injure a passenger, a driver and their child, to avoid potentially killing, say, a parent and their child who's in front of the car. And so it's got to be complicated and messy. The public concern, rightly so, when you see incidents like this, will outweigh any amount of statistics we can show to do with the fact that the number of road deaths may have decreased by 30%. That is going to be a really huge issue, at least in the Western countries. And you look at something which apparently is so cut and dried as vaccination, and then you take this much more nuanced situation. It is going to be really complicated, and if we don't face it, I believe we're going to lose the opportunity to save millions of people. That's
You know, and again, on the policy side, there's a lot of costs associated with building these complex systems. Even before you put in AI, the Volkswagen example recently, the attack surfaces on OnStar that were discovered by Savage Instinct. So I'm wondering, given that fact that companies are going to be trying to find a way around this to try to control costs, are there any design structures you can put into an AI-based system that will help establish policy for self-checking? Or do you think that that's just an unsolvable problem? It's always going to have to end up in court.
Well, potentially we can have a kind of certification for various types of specific applications, where some body or bodies would actually make sure that various types of best practices and potentially, you know, ethical constructs are actually in these systems, embedded somehow.
Again, open societies, I would love to see it the case that you have to reveal your hash defines. That cannot be something which is kept secret to some government committee.
It may also be that if these systems, as they're operating, they will be collecting data, and that it would be interesting, for example, for your automated car to report back, or your fleet of automated cars, to report back what are the typical G-forces involved on the passengers when swerving to avoid a deer in the road, for example. So the systems might serve as data collectors that might inform what's eventually still going to have to be a public policy decision.
I mean, one other issue I just have to say it is, I mean, in Andrew's example, you're presuming that in your ontology, there's a notion of a deer, a person in a car, an orange cone versus a squirrel or, you know, a tree or something else. And the question is, how far do you go?
Bill Shirless hates squirrels, by the way.
I live in Squirrel Hill, what can I say?
Agreed. There's a
It's
whole
a frame
bunch.
issue again.
There is massive engineering and technology needs and also.
Systems vary one from the other about the performance, about the priorities. So my targeting system, weapon system, requests geospatial information about the target area. And if you're going to find that the system giving the information wants to be sure that you know these are civilians and non-military targets. And the system is going to interact where they have conflicting priorities or question one another about this.
I would like to think so, and there's a very interesting thing going on at the moment in military doctrine to do with it is a good idea to work out in advance of these terrible situations rather than in the middle of them how these trade-offs are going to occur. My preference is that stuff is written down. We might not like the answer, and we certainly won't all agree on the answer, but if it's written down in advance, we're actually in a better situation than we would about if we're just making a very rapid